Hello, welcome. Just setting things up here. 1 second. Alright, there we go. So, welcome. Yeah, so we are in the middle of making some improvements to the game editor for the game that I'm making. And possibly other games as well. So, yeah, right now we have this scene editor. Let me just show you. Well, I guess I can run the game show. Or the game editor. Oops, I think I pressed it twice. Should really have like a guard for that. There we go. So let me show you here. So here we have a scene editor. So you basically create your level here. You can drag in entities and you can move them around, delete them, whatever. You can yeah, I mean that's basically what you can do. You can also connect to other scenes here, but anyway, the thing that I want to do here is that, well, let me explain. So the way this works is that you have all these entities. This entire level is then stored in a JSON file. So basically just working with JSON files here. So it's basically just a data file that keeps the information of where are all the entities, which time map we're using, and the entities, the position, the type of the entity, and you can also put in metadata, but this is gonna disappear. But it's basically a way to customize the entity. So that's basically all this JSON file contains, and then the game editor will load in the JSON file and it will create the level from that information. So you design the level in here, and then in the game it's gonna load in the data file, the JSON file, and is gonna generate the level and make it playable. So one thing that I want to have is I want to have sort of more advanced entities. And for example, if I want to have a door somewhere that is kind of blocking the player, let's say I want to have a door here or something, and that's blocking the player, and then I want to have a button over here maybe, so that when you press the button, it's gonna open the door. But how do you connect those to do that? Well, my idea is that I will simply use components, because we are using ECS in the game engine, and it fits very nicely with this type of thing, because if we then support components in the editor, let's say we add a button here, and let's say we add like what happens when it is triggered. Well, maybe you can have a component for that is called something like open door, or I don't know, something like that, and then that component has a property that links to whatever door you want to open. And so so then you can have a component. Let's say you have the button. Let's say we add this one as a button for now, and let's say when you select this, you get the components list here of what components it has, so you can add more new components as well. So let's say we have a component over here. Well, now we have a health component that we can like drag in and add to the list of components for the entity, and then you will be able to change the properties of that component. And that's what we're working on now. And then in the game engine, it's gonna see that, okay, you have a component here. It's gonna be like when the button is pressed, you have a component that opens a door. So the game can know how to connect those things and will like set that up for the player or for the in the game engine. So so what we've done for like until now is we've made this component. We've made the component. We've defined the sort of structure of the component. We have a basic document here. We don't have any. So this is the component editor, but we don't have any sort of any way of adding like properties, editing properties and stuff like that yet. But that's what we are going to add next. I'm also going to add a icon for that, for the component. Let me actually do that real quick here. Let me open up the icons and let me show this window here. Yeah. So let's go ahead and do that. Okay, so let's just make, I don't know, let's just create a new icon maybe over here. And we can, so this is going to be a component. It's going to be sort of related to entities, but I was thinking of what color it should be. Maybe a little bit more like that, maybe, I don't know. Give it a little bit more color. Okay, and then I mean basically it became like a sad face. So what is a component? Maybe just like, you know, maybe like something like this. Oops. I don't know, really. Or maybe actually like building blocks. I don't know actually. Yeah, I guess something like this. You have some kind of structure here, right? And then something that gets added onto that. Something like this, maybe. I don't know. Well, it's not that important. I just want to have something different there so it doesn't look like a directory. Okay. Let's go back here and we quit out and we add that icon. So this is gonna be 0, 2. And we can go in and see how that looks, just to make sure it works. Maybe I should try turning on like the incremental, see how fast it goes. Components. So there we go. Now we have that other sort of icon there. All right, and let's see. So yeah, here's the name. The name input. I don't know why it's so long. I guess you could set like a width on it, but yeah. So we only have like the name. We have save button. We have ID for debugging purposes, and you can also set the name of the component, which will be sort of the main way that the game engine will know which component you're talking about. I think, yeah, it's gonna be, I mean, you could look at the ID, I guess, but I think it's more readable for a human to actually look at the name. But it's gonna be like, if you change this, well, then you can change, I guess, a string in the game engine as well. But anyway, so what we want to do now is, well, if we go to our component data, so here you can see we have ID and name, but we also have properties, and that's what we want to be able to edit now, which is basically like a JSON object. So you can have anything in there. You can have this property is going to be an object, but then the object has a bunch of fields. Oh, my LSP is not. Yeah, the object has fields. The fields is basically a hash map from strings to properties, and then the property can be like anything. So it can be an object, it can be a string, integer, float, and also, so these are pretty straightforward and simple. But then you have the references. They're gonna be a bit more, well, asset reference, we actually have an input for that, but the entity reference is gonna be a bit different. Also, yeah, I just thought about that. The asset reference, we actually probably wanna have that you can set a type here. Yeah, so this is probably gonna have an asset type, which is gonna be a document tag. So because that will determine what type of asset you can have in the property. So if you only want to have entity types, you can have that. If you only want to have like textures or animations or whatever you want, you can specify that. That's the idea. So let's import that. Okay, and yeah, so let's start working on the layout, on the UI component. So here is the code for that, and we've started on, like, we have everything that we had that you could see in the UI there, like ID and name and stuff like that. Now we want to move on to the property editor. So what do we want to do here is the question. Well, one thing we probably just want to have, let's try using like begin child or something like that. So this would be properties, and I believe you have like things there, defer and child. Okay, let's try what that does, if it does anything. Okay, we got some errors here. Document dependency loop detected. Okay. Oh. Right. Okay, so there, I think what's happening is that since property is like a part of the type, and tag depends on the type, document tag, we have a problem. We have a circular dependency here problem. So I think what you want to do is, well, let's see if it can be solved with a pointer. I'm not sure actually if it can. It's weird that you can't have the tag, because the tag is only like the enum part. Like if I explain what's going on here. So here we have like every document is stored as a document content. Well, this is part of it anyway. This is the content of the document. It can be either of these things. Now, if you want to talk about the tags only here, so scene, time, animation, texture, and you don't need to worry about the actual type here, what you can use is a document tag here, which itself is defined over here. So this is meta tag document content. And what this does is, well, we can't go to the code now because the LSP doesn't work. But what it basically does is go through all the sort of fields or tags in document content, and it produces an enum from that. What you also could do is you could define the document tag here as an enum, and just do this. Okay, so there's our enum, and then instead of just putting enum in here, we could put document tag in there. Okay, so that, I think that will actually solve it for us, because now you're sort of, yeah, this is the source of truth on what types of documents we have. And then this one actually uses that to, so you can use this to sort of enforce also that all of these are defined. If we remove this, that's going to be a compiler error. Yeah, enum field is missing. Yeah, so field component is missing, so we have to add it. Right, and if we compile now, still get some error here. Okay, so now we have a different, so that actually solved the issue that we had there. Now, we do need to sort of define it here first, but it's not going to be that big an issue. It's just like one extra place to define it, but it's like, I guess it's more readable anyway now that it's its own thing anyway. So, but yeah, so it's not that big of a deal. Anyway, let's continue here. What is it complaining here? Value of type bool ignored. So let's do this. I'm pretty sure this is how you call it. Okay, so it doesn't show anything. No, we don't get any help from here. So we have a child. Let's try and just put some text in here. So this is, I want to just put text like properties. Okay, there we go. Now here's the properties, but I want it to be, okay, let's make a separator. Okay, maybe we can just skip this begin child stuff in that case. Separator text. Okay, let's make this separator text instead. And maybe we don't need this, so what's the issue here? Expected one argument, yeah. Okay, so there's no formatting on the separator text, but yeah, now we have a separator here. It says properties, so that's nice. It's more like a title type thing. So now down here we want to have our properties. Now, how do we actually want to do this? So I haven't really thought about the UI that in that kind of detail. So it's going to be a little bit of a discovery progress here. But I'm thinking, well, we're gonna show the list of fields and then it's probably going to be some sort of recursive view of properties near. I believe that ImGui has actually a built-in tree view as well, where with nodes and stuff. So we could probably utilize that for each field, and then what we could do, we could also have like a plus button or something that adds a new property. So let's start with that. Let's make a button here, plus, and let's set the width to like 16 maybe. Okay, let's just see how that looks first. Okay, now we got a little button there. Maybe it needs to be like 24. Okay, so there's a little button, and when we click it, we want to add a property. Now, I don't think I have like a really good way of doing that yet, but let's go to our component document, right? And we want to add a function called add property. And this is gonna be a void. Okay, so we're adding a property. Now, I think what we want to do is we just want to add it in with some sort of default name and nothing else, I guess. Like the type of value of the property is also going to be interesting to select, because, well, from the start, I guess it's going to be nothing. So maybe actually we want to add, for our properties, we're going to add another property that is like not selected yet. Or we could just force it to be a float as like a default. Yeah, we could do that. So let's do that. Let's see. So we have document, we have persistent data, and we have our properties. Okay, so what we want to do is we want to go to properties. Properties is a property object, and we have fields. So we basically, do we want to add the logic for stuff in here though? Probably yes. So let's add a function somewhere, like here. Add property, like add new property, let's say. So it's a brand new property. We need self. Now this is going to be property object, mutable, and nothing else. And then, I mean, it could be that you add one. It could also be you press plus, and then you get a little context menu that shows where you choose the type. But we can also just add the thing like in MongoDB when you. I'm not sure if you're familiar with it, but if you are, it's like they have an interface where you add a new property, and then it's like defaulting to string or something, and then you can select another type from like a drop-down box or whatever. So I think I'll just do the same here. Just populate, make a new thing, populate it, and it's gonna be good. So what we do need is we need some sort of unique name, new property name. So generate new property name. We're gonna need that, and then that's probably gonna be like allocated, yes. And then we're gonna say properties, no, fields, and we want to do put, because yeah, we don't have actually no, maybe we'll assume capacity here. Maybe we actually do assume capacity, because I really don't want the pointers to the properties to become invalidated, especially if you're in a tree somewhere. Yeah. Let me just think if that is an issue. Like, let's say we're iterating through the property fields. We're drawing each one at the same time. You're not gonna create a new property while drawing it. But let's say you're iterating through for some other case where you do need to mutate, maybe deleting the property. Yeah. But then you would probably do like we've done before, like have a bool or a list of things that you want to delete, and at the end of the iteration, or at the end of the whole the end of all iterations, it's gonna delete the thing, so it doesn't modify the list while drawing it. Yeah. So let's just use put, and we'll see if that becomes an issue. Put, and then let's see, we want to, so first you have the key. Now this is just a string, so I think, yeah, it's a string array hash map. So we'll put the key there, and then I think you put the value in directly. So let's just do empty, maybe, and then we'll have an empty here, which is a property, and then this is, I'm just gonna set it to be a float. That's like the default thing. And then we'll add an empty here as well, which is a property float. And then value, let's just set it to 0. I'm not even gonna set it to like undefined. Okay. So now it's like defaulting to a float. That's fine. It's probably like the most common thing that you would have. All right. So then what now? Yeah, so now we get an empty property there, and we can even, yeah, I mean, I guess that's actually it. Yeah, so then we're done, and we also catch unreachable here. Okay, so now the thing we need to have is generate new property name. Now the idea here is that oh yeah, we also need to deinitialize the keys here as well. I forgot about that. Oh man, and the strings are gonna have to be like transformed into 0 terminator strings. No, because they're gonna need to be able to work with the inputs of, oh man. Okay, this is gonna be a bit more tricky than I thought. because the strings in here, I'm just gonna double check this. String array hash map. Wait, I'll show you. So, here, wait. Yeah, here's the string array hash map unmanaged. So it has entries, which is a data list, which is a multi-array list of data. But now multi-array list is like a structure of arrays. So it takes a struct, like data, which has key and value, and it turns each property into a list. So it turns this struct into, well, I guess hash as well, into a struct of each of with these properties, but they are all lists now. And yeah, so it's a more efficient way of like keeping these like close to each other. Okay, which is more efficient for a number of reasons, and computationally. Okay, and then, well, that's not the issue here. The issue, I'm just looking at how this works here. I'm just trying to figure out, because we're passing in some like string array hash map unmanaged. It has one parameter, which is v here, which is type. Let's just see what the source is. So here we have that. Okay, so it passes in this as a key type. So that's not zero terminated, like a zero sentinel string. So yeah. String context. So here's the string context. Maybe it works for zero sentinel as well. I'm not sure actually. Equal string. What's that? Mem equals, okay. What's happening here? My browser just didn't stop working. Equal. So is it looking at Sentinel? Because the type doesn't say anything about Sentinel. But I've seen sometimes you can pass in, you can switch between zero sentinel and non-zero sentinel sometimes. So it's like, so it's a bit weird. Sometimes it's like coursed, but then it also at one time actually crashed because of sending in the wrong type. But the compiler didn't complain, but the runtime actually crashed. I'm not actually so sure exactly what the situation was, so I cannot say it for that for sure, but that's what it felt like at the time at least. But anyway, so I was just checking here if it has any sort of handling of zero sentinel stuff. Method has unique representation. Right. So okay, so it's like a comp time thing depending on the targets, I think. Alright, but it doesn't look like it, so yeah, let's go back. I don't know why the browser is like super laggy. So anyway, This means that we can't, we can't really use these for the raylib or for the imgui inputs, because the inputs since imgui is like a C library, it requires all strings to be like zero terminated, so it doesn't really work for these kinds of strings. So we have to change this. I think we might even have to implement our own thing here. But if we actually go back to the browser here and look at, hopefully it doesn't like lag too much, and we look at the string context. Now let's actually just copy this. So you can see we have two things. We have hash and equal, and hash has is using hash string, which is just using some random hash function. We can still use this hash string because we are gonna have a string. However, I'm gonna look at this hash function. This also takes that. Do we have like a hash 0 sentinel thing? Maybe 0 sentinel can just be pointer casted here, because it's still gonna be well, you don't want to hash like the garbage after the sentinel, probably. So I think, yeah, we'll need to do this, but then, yeah, I think we'll just, well, actually what we can do, we can just use the slice to function, or the whatever it was called function. But we can basically copy this and create a version that deals with that has the key is actually something else. It's actually our own sort of thing. So we need to, I'm gonna go to our ID array hash map, and we want to make a new file, which is gonna be the string z array hash map. And now we also have the opportunity to make this what's it called, JSON friendly and all that as well. So I'm just gonna call this string z context, and we probably need to make this a function actually, because string z has like a max capacity thing. So max capacity, and that's gonna be like a usize, and then it's gonna return a type, and this is the type we return. Okay, so there's our string z context, and now this is the key. So this is actually we can actually do this. K is equal to string z. So let's import that. Okay, and this is gonna be string z. Well, it's gonna be k actually. A B. Okay, and k is gonna be string z with max capacity. Okay, and hash string is actually then standard. Where did it live? Array hash map, I think. Yeah. Dot hash string. So let's use that as well. But here we actually want to use, I think, slice to. Let me check here. Because there was another function also that automatically like took to the end of the like standard mem slice. What was it called? Span. Takes a cent. I'll show you. Takes a so span. You pass a pointer, you get a span. Takes a takes a sentinel terminated pointer, returns a slice, iterating over the memory to find the sentinel, determine the length. Pointer attributes such as constant percent. So it's basically if you have a zero sentinel slice, and you want a slice out of that goes from the beginning to the 0, then you can use span to get that pointer. So it's a really nice generic function to do that. So standard mem span. There we go. And you just have to pass in the pointer. And that's just gonna, you know, read out where does this thing end. However, we already have a function for that actually. So we already have, like in string z, we have a function. So you could pass in buffer, like this buffer, because that's just the underlying buffer there. But we have some function here somewhere, slice. That's right, which is a slice too. We should really you could use span here also, but I'm gonna keep it like that. But so slice, and that will return our slice that will basically calculate where the 0 is and return a slice with the correct length. All right. Now let's do the same thing here. I think we can just use mem equals here. I'm just gonna double check. The equals string. Whoops. Yeah, that's just it just uses mem equals. So I'm not sure why they did it like that, but so we can just say mem equal a and b, and now we don't. Well, actually, no, because these are string z's. I don't think we have like an equal function here. We should probably just add an equal function here. We could do that, or we could. Well, I guess it's nice to have its convenience. So self other. Actually, the other. No, let's make it so that it has to like equal something else with the same max capacity, which is kind of bad though. Maybe others should be like any type. I'll forget about. I'm not gonna do that. What I'm gonna do instead is I'm gonna take the slice here instead. Yeah, I'm gonna do that. Okay. And b index. I'm not sure what that means, but it's not used, so yeah. So this is our context for the string. It what's the array, like the array hash map needs in order to know how to deal with the keys. And yeah. So let's now continue with defining this thing. So here's another sort of hash map wrapper that we have. I think I'm just gonna copy this and switch out stuff that we need. So this is gonna be a string z array hash map. It's gonna take a type. It's also gonna take max capacity. This is also going to be comp time, capacity, which is a use size. Let's also make this comp time. 1 second here. All right. Yes. So we don't need you anymore. Yeah, now that's comp time. And okay. So we have our inner sort of map here, which is not really an auto array hash map. Well, we probably want to have an auto on the type, on this type, but not on the key. So we'll do array hash map unmanaged. Let me check here. Yeah, because then you have to, so you only have to put the context for the key. K, V, and context. The context is for the key, I think. Yes. And the final u size in the equal function represents the index of the key is already inside the map. Okay. Store hash. When false, this data structure is biased towards cheap equal functions and avoids storing each key hash in the table. Oh, okay. I mean, it is kind of cheap, so I guess we'll set this to false. I mean, I don't think it's gonna matter that much. Well, it's not something that we can sort of decide right now. So I'll just set this to false. But we will want to use this. We put the key here. The key is actually this, except this is capacity. Capacity, yes. Oh, did I misspell it up here? Capacity. No, city. Capacity. Yeah. There we go. Yeah, so the key and the value, and then we need a context, which is going to be the string z context, and we put max capacity in there, and then the last one will set false. Oops. All right. Yeah. So now what? Now we have that. Basically everything else should be sort of the same. Well, we do have this thing here. Let's make the inner map hash map function or type here. So we'll just reuse that, so we don't have to type this thing out all the time. Okay, this is an inner hash map. And then that is that one. Do we have it anywhere else? Yes, over here. Hash map. Maybe we should make like a wrapper, like, and I mean, I don't think it's warranted, but make a wrapper that does all this, because now we have a lot of like JSON parse and all that, JSON parse from value, JSON string file, like. Make that a wrapper around. So you basically take a comp time inner hash map map, and then you wrap the JSON thing around that to make it like JSONable. I mean, I guess we could, just for fun, actually. JSON array hash map. Because the thing that's basically the only thing that we're doing here. We're doing all this crap. Well, this is kind of, we need to serialize. Yeah, this is kind of bad. Okay, maybe not. Maybe not actually. Maybe not. Whoops! I just quit the whole thing. Array hash map. Okay, maybe the LSP will wake up for a bit now. Alright. Let's see. So, what we need to do now. The init should work. I just need to import allocator. believe it's in mem. Yep. Parse options. This is JSON, I think. All right. Okay, so we do have these things like deserialized key. So here's a little bit different. So this is the JSON. When we're parsing an object, we are going through, looking at a token. This is where the property, I think, the key, property key starts. We get a key here, and we're freeing it up. So this is just a string. Well, it doesn't say anything about it here, but okay, it doesn't. Okay, yeah, we don't get anything because source is like any type, so we don't actually know what this is in here. But we free this. This is a string, so we free it up. Then we create a UUID, but we're not doing that for this map. We are instead making a string Z key. And this will be string Z with max capacity. Or this will be K. Let's make this as K. And then this will be initialized. And we need an allocator. And we need the initial slice, which is K. Except K is not actually zero terminated. So if we go here, do we actually need it to be zero terminated? I'm not sure actually. Like this one, it takes U8 capacity and then a sentinel, and then we use set here to set the thing. Set takes that, it slices to this, but slice to actually accept it is like if it doesn't find it at the end, yeah, then it returns the full length. So I think we can just use this, but we can just pointer cast the key here in case it's not zero terminated. Well, it's not going to be zero terminated. It's like a JSON parse string that we get here. So, but we'll just pointer cast that. All right. If we need to, I'm not actually sure if we actually need to do that. Does this return error? No, it doesn't. Okay, cool. So now we have the key, and now we can use it as an actual key in the inner map. And yeah. Okay, on to the next function. Value is that. Options is also parse options. Okay. Yeah, so we don't have a deserialized key function. What we're trying to do now is, well, we're parsing from a value. So we need to duplicate key. I mean, this is oh, it's parsing from that. If it's an object. Oh, okay. So we need to, or again, convert this like this. Okay. Right. Inner parse. What's this now? K. It's KV key pointer. And yeah, no, that's it. Pointcast. Yeah. Okay. And then I just got reminded there on deinitialize, we also need to deinitialize all the keys because they are now strings. So we need to go to map and keys, and we need to say deinitialize as well on the keys. All right. So now we're deinitializing all the keys, and this shouldn't work. So this is not gonna work because the key is, we don't have a serialize function. I'm not sure why it doesn't give me an error here, but we don't need to dereference. So this is now what did it do? Serialize. So this takes a thing, makes it into a string. That's right. So I think we can just put this. I think we can just. No, this requires a string. That's right. I wish I could just write out a string, but I can't do that. I have to like turn it into a string, then put it into object field, and then deallocate it. So we have to do that. Actually, you know what? We could actually just put. Well, we could just put slice there. Yeah. We don't need to do that. We'll just put slice and we'll do a pointer cast. Because this returns 0 terminated, it doesn't have to be. Okay. Alright, so now we should have our string Z array hash map now. So I'm not gonna bother calling it unmanaged. You know. But where did we were before? It's probably gonna be like component persistent data. Yeah, that's right. So the properties, this one, yeah. Now this guy needs to be string Z array hash map, and we put a maximum, like this is going to be sort of the maximum capacity that's going to be allowed for each property key. So I'm just going to say 32 is probably enough actually, but I'm gonna double that and say 64. That will be plenty of space for your property keys. If you have more than that, then that's, I guess, a problem. Also, we're gonna add something here. We're gonna add string Z array hash map as well. String Z array hash map equals link. There we go. All right. String Z array hash map. So now we have as an array hash map where the keys are actually very compatible with this setup with JSON serialization and the integration with a C library, which is IMGUI, because of the 0 terminated strings. All right. we don't have clear and free. I'm just gonna use the initialize right here. The value is gonna be dot. We have to type dot map here. Okay, and then we need to call the initialize like that. All right. Let's just use clear and free because that resets the capacity as well. Yeah, it removes the backing allocation. It clears the map. I'm just gonna check what this does. So it clears the map. Shrink and free. So we're aligning, we're allocating new length. What? Oh, it's shrinking to 0, yes. Right. So we're doing a clear and free, which frees the bytes and resets the data. Okay. Well, okay, whatever. So yeah, this should be good, I think. Free, what am I doing here? Free. Well, I was trying to free the key, but now we don't have to because that happens in there. Okay. That's right. That's what started this whole mess, I think. Yeah. Okay, but now we should have a good array hash map going on here. And I think we probably don't really need JSON parse now or stringify because that's handled in the map itself. So we don't need this, which is nice as well. Now for clone, it's gonna be like this, I think. Yeah. And then, whoops, what happened there? That. Okay, and here we need to do map put. Okay, and the put and we're putting a value. We could make a convenience function for this specific type because we're gonna put in a name that is supposed to be, so you don't have to like put a string z there. So let's do that. Just a convenience function for put. So let's check. This is gonna be this. I'm just gonna say this. Allocator, key value. What type of, so out of memory error. So let's just skip that. And then it doesn't return anything. Okay. So first we convert the key to a string z. Now this is, we probably want to duplicate it, or maybe we don't actually. Well, we are duplicating it because this is automatically duplicating it. So the color needs to, so key is duplicated. I'm just gonna say that as a hint as to what to do. Okay, so color needs to free it. Okay, so we initialize it here. We then do self map put key value, but the key is string z key now instead. All right, and the value is, oh, we don't actually, oh, it's t. It's not conventional. Let's change that to v. Okay, that was close. All right, so key v, yes, very good, but this is not a key, this is any kind of slice. Okay, all right, now back to here. So we make this new name, we defer free that, and this one also needs allocator, key and value. All right, there we go. Now we should be able to add a new property. Well, okay, we need this as well. Generate property name. So the only requirement here is, well, there's two requirements. One, it should be unique. So unique. Two, number one, it should be unique. Number two, it should be some sort of readable, it should make sense to the user. Of the editor. So I'm thinking just saying like new property, and if that already exists, then, well, we can do fields map pass, no, what would that be called? Contains key, contains. Okay, so if it contains well, let's actually do this. Let's make a, well, first we want to check if it contains new property. Okay, does it contain new property? Base name, because we're gonna need it as well. I'm gonna put numbers after there later. If we have it, if we don't have it, we return that, and we don't have to free it, I guess. Well, we do want to free it, so we actually need to get an allocator as well. So let's duplicate that. Okay, but if we don't, if we do contain base name, we need to find another thing. So what we do is we make a integer, start at 1 or 2 maybe, yeah, and then we do a while self fields map contains base name plus man, how did you oh man, was there like a comp time format? Oh yeah, comp time, no, print, what? Okay, I guess even though it's called print, that makes me think it's actually printing to the console or to the terminal, but it's we'll standard out, but it's not. It's I mean, it might do that and also return. No, it doesn't do that. Yeah, but this is what we want here. So buff. Yeah, it does like a buff print thing. Yeah. Wait, buff print. Print the formatter string into buff. Okay, so it's like yeah. So buff print is not actually printing anything to the screen. We're just it's like using this conventional name print here to print like a print interface into some writable thing. Okay, so the format is going to be base name and the actually we can do this, make it a little bit more readable maybe. Base name plus and then the number there, and then this is going to be the number, so this is going to be I. Okay, is there a do while loop? No. Well, I guess we could take this and put it there. But we do want the okay, let's just do this. Let's just do true. Okay. And then I plus equals 1. The key is this, or the name. Candidate name. All right. Yeah. And I will say if we don't contain the name, that means it's free to use, so we return it. And now we have to also duplicate. I guess if we already no. This is not comp time print. We cannot actually. We have to allocate here, so we have to actually, because this is not comp time. This is not comp time. We could. The interesting thing is we could actually make a comp time sort of up to a certain point, up to like, I don't know. You could make, let's say up to 10. You could make a comp time. I think what you can do is like a switch on something, and you have like a, I don't know, an interval like this, I think, and then you get that, and that is actually comp time now. This is comp time. It doesn't say that, but it's comp time. So what we actually need to do here though is we need to allocate this, so it's actually gonna be like alloc. Also, this is wrong here. This we actually need alloc print here. unreachable, and we need an allocator as well. Okay, so we're allocating the thing, and then we also defer. No, we don't. Well, yeah. So if we return, we don't want to free it, but we do want to free it here. So, and should we have like a max and then just quit if it's nah. I mean, in case something is wrong with the code inside that it can't actually quit, I think we'll just have a max I at, I don't know, 100 something. If I is more than max I, then we throw an error, then we do like a panic here. I like generate new property name, could not, well, let's do could not generate a new property name too many iterations and then maybe put I there. Okay, so at least we quit out if I is, so it doesn't become an infinite loop here. All right. Let's see what now. Generating property name. Yeah, so now we should actually have a name generated here. It's going to be allocated, and so now this comes out allocated and we free it up as well. But when we put it here, actually we need to use this. Yeah, so when we put it here, it's gonna copy or duplicate the name string here, so that's fine. Okay, so now we have a way to add a new property. Now we just need to go to our thing, the UI. Yeah, where is this? Here? No. Layout. Here. And here we can say add property. Yeah, I guess we can call it like add new property. Yeah. Okay, interesting. It renamed it at the component document, but it didn't rename it here. Okay. Right, so now we should be doing that. Let's actually test this out now, because we should be able to add a new property. It's not going to be visible in the UI, but it should be visible in the what's it called? The JSON file. Okay, we have a hiccup in here. Oh, right. So properties, add new property. Oh yeah, we need an allocator. That is correct. And this is passing our property.
allocator. Okay, what now? 55. Oh, context is actually used now, so great. Component document 36. Oh, not a comma there. Okay, component property 127. You need an allocator, that's right. And dip. Expected strings at found const. What? Oh, right. So we have to actually make that. Okay. Actually, let's call this. No, it's, yeah. Actually, you know what? Let's make a convenience function for that as well. So let's do, we have put, let's add contains. Allocator. No, we don't need, well, actually, we kind of do need allocator. And then the key, which is not that great, I guess, but maybe we'll have like a weird version of string Z where you actually don't allocate anything. You just pass in the thing. I mean, I guess we could just force that. We could actually enforce that. So we could, if we don't have an allocator, we say map contains, well, we need the key, so there's going to be string Z key. And there's going to be string Z, well, it's going to be key. And then the buffer, we just set that to be the buffer. And then we can simply use that. Then we don't have to reallocate the thing. Okay. Oh. Expected 3. Oh yeah, this is. I mean, I'm just gonna say U8s here. Map put error union. Yeah. Catch and reach one. Actually, is this only like what happens if you put the same key in? That's just gonna crash the thing. Okay. Okay. So yeah. Let's see. So now we can do contains like this instead. And contains needs to return bool. And here we're just gonna do a pointer cast. There we go. And here we also use this one. And no, you don't have a. Oh, that's fine. There we go. Invalid format string. Here. When I use size. Invalid format string. I for the type usize. Huh? Where do we have that? On this one. Oh. Okay. Podcast discards const qualifier. Oh, okay. Right. Yeah, that's a problem. This is supposed to be writable, I guess. Yeah, that doesn't work. Well, at least I mean I can't think of a way easily now to fix that. Unless we duplicate it. I was thinking of maybe making like another version of string z, but I mean, I guess you could make like a const version and a mutable version and then have that as a union enum. But or you could also put well, these are, yeah, they are going to be modifiable. I guess that's also bad because if, okay, I just thought about this. Like if we have a hash map that is like modifiable, then we need to rehash the hash map every time, every time you change the thing. I guess that's possible. It's not really that huge, I guess. Okay, let's actually just duplicate this key here. Okay. So we do need an allocator. It's just a. It feels like it. I mean, this is possible to work around, but it's like I can't be bothered right now. Let's do allocate. No. Duplicate. Wait, what am I doing here? So this is gonna be the key duped. Dupe. Let's just dupe Z to make it the correct type here. U8 key. Catch unreachable. Defer. Allocator free. Key duped. Okay. And then the string Z is just so we don't need to now make a new string Z. So now we can just put this in here like this, and that should work. Fingers crossed. Okay, property 112. Yeah, so now we need to put allocator here. And it crashed. Interesting. Request error processing JSON missing field. So let's open up the JSON here. Components. So we've got ID, name, and properties. That looks good. Is it complaining about like map or something? That might be the thing, because we did remove like the JSON parsing. Yeah, I think it's because it wants to have fields. So we could take it back like the JSON parse stuff to have that like better incorporated, I guess. Because it would be annoying to have to mimic that structure on the front end, or I mean on the. Yeah, I mean I guess it is the front end, the game engine thing. JSON parse. That's gonna be, I think, this type, and then we have source and options, and we return a thing the object. Okay. Now we will grab the hash map. Is going to be in a parse. And the type is this type. And we have an allocator. Oh yeah, we have an allocator. And we have a source. Oops. And we have options. And then we also do try. Okay, so now we have that. And we simply return fields equals hash map. Okay. And now we need a wait, we don't have a self. What am I doing here? I don't think we have a self there. No. Now we need a stringify. Now you need self. And you also have the JW. And something like that. Okay, and then we simply do write try bits. Alright. Hub function. Okay. Okay. Yeah, let's try this now. See if we get the same error. Okay, I think maybe this isn't a pointer. All right. Okay, there we go. Now it works. So let's add a property. Nothing happens, but when we save it, exit, let's just try if we can reopen it. Okay, it doesn't work reopening it, but we can check out the JSON file. And here you can see that we have our new property here, and it's a float with the value 0. All right, and that's basically the idea. So I'm not sure why it doesn't work when parsing it again here. Let's see. Memory. Is it some sort of... Okay, it's indexing out of bounds. So when it does slice to, it fails for some reason. Set initial, where is that from? Here. This one. So we are getting a slice in. Length of it might be the pointer cast that's messing things up here. We'll see. It's this one, yeah. So is it the type that's... No. Can't be. It's over here. Yeah, it's this one. 77. Length slicer. So what does this produce here? Okay, let's just check if this is correct for 944. Yeah, it is this one. And so check out this one. We have one array, many. It's not many, it's a slice. And then we have a sentinel. If the sentinel is equal to end, which it is, then it tries to find the sentinel. So does this just go like way beyond the length of the slice? Yeah, because this is not a, this is like a, we don't know the length pointer. So what? Okay, so that's the issue, I think. Where pointer casting, it's not able to determine the length properly. That's weird. Okay, what if the zero terminated actually doesn't have a 0 in it? Like, that's entirely possible, right? Oh. So this is looking for like vector support. Okay. Yeah, it just does this. So I think that's the issue here. Well, I thought that it would end at the, like, yeah. Okay. Maybe we can have some sort of guard against this. Slice to like you could also do something like this, like new slice 0, and then you say min of new slice length and index of sentinel 0, pointer is new slice, I think. But the issue is it's like it can potentially run into memory that is not accessible as well, so this is not a solution that sort of works either. Like, I want a version of this that actually cuts off at a certain point. Like with a maximum length. Start index. You know what, I'm just gonna do this on my own here. I'm just gonna find out this on my own. So we will simply do for to new slice length get I. This is the end. And if I is equal to 0, no, if new slice I equal to 0, then we break I. Else we say use slice length. Okay, so that's our thing. Pretty compact thing for what we wanted to do there. I really like this way of doing things. Okay, so that's the end, and then here we don't need to do this, we do end instead, right? Because this is going to be the length of the thing, right? I'm pretty sure it's not like inclusive, something like that. Okay, let's try it anyway. Whoops. Press two buttons. Okay, now it seems to work. Let's try and add another property. Save. And when we quit, we get a crash. Leak. It felt like it was more than a leak. Or was that the other program? Yeah, this one has a leak. Okay, I don't care about that one. Here is the crash. this is not a leak. This is a seg fault. Yeah. Memset. So is it like end -1? I don't know. Okay, now we can't load it in. Okay, let's look at the JSON. How does the JSON look? New property 2. Well, that looks good. What is the error now? Panic integer overflow. Okay, so it's probably like this then. Should be able to load it now, I think. Okay. But then when we quit, there's a seg fault, I think, yeah. So it's when we free the buffer. Oh. Wait. Let's see. Wait, did we actually remove something here? No, set format should be fine. So we get the property name. That's properly duplicated. The new property name is here. We're freeing it up. We're putting it in here. We get the key. The key is then initialized, which will duplicate it. Well, it's not. Yeah, it is duplicated. Yeah, because we're initializing a new buffer. Okay. So. And then in deinitialize, we go through each key and deinitialize them as well. Is that when we actually get this? Fields deinitialize. Yeah, this is where the issue happens. Because my thought here was that we had put something weird in the key that is like not properly initialized, but I don't think so. Is it because of the pointer cast? So when we use this, you know what? I'm just gonna force this to be 0 terminated. There, so we don't pointer cast it. Because there might be some slight difference in the pointer, how the pointer is represented in memory, and I don't want this to be the case here, so I don't want that to be the thing that makes it break. So generate new property name. This is now a 0 terminated name. Let's just make it 0 terminated. Instead of dupe, we're doing dupe z. Instead of alloc print, we're doing alloc print z. Okay, and there we go. No, we still get a crash when we exit. Interesting. So that might not have been the issue then. Self is initialize. Yeah, that's why we initialize that thing there. Is it something to do when we... Okay, let's look at the... string z. Let's look at the JSON parse thing here. Here we also do a pointer cast. I think what we do is we duplicate it here as well. Key 0 will do. And let's do a dupe z on key. Actually, let's do a try because we can. And then we also defer allocated free kz. And then we put that in there instead. There we go. Oh yeah, undo, please. You wait. Now I've still got the crash. Okay, 1 second here. Okay. Segfault, same issue. Man, what is the issue? I wonder. Okay, yeah, we need to update this as well. See if that was the issue. Oh, forgot to free it. But it's not why it crashed here. Still the same issue here, yeah. Okay. let's try a couple of things. I'm gonna try and remove the file. Here. So I'll delete it. Yeah, of course that crashes it because you get a sig fault now when it tries to like deinitialize it. Yeah, invalid free. Okay, but can we start it now? No. Why not? Seg fault. Oh, is it because the editor session is now in a like invalid state? Yeah. I'll delete this last one. Okay. Wait, why did I still get that? Oh, because of the current open editor, okay. Yeah, but now it's null. Wait, does I still get a crash now? No. Okay. So yeah. So now, you know, we can open and shut, of course, because we're not dealing with the components. But let's now add a new component. And let's create it. We open it up. We now quit. And you see, we don't get any issues. So it's not when we create the thing. Well, okay. Okay. Let's wait, why can I 2 visible items with conflicting ID? Oh, okay. Well, let's delete this. Why is this not removed? Okay, weird. But anyway, let's create the thing again. So what I want to test here is we open this, we add a property, we save it, and then we exit. And you can see now it doesn't. There's no error when quitting. So what does that tell us? Well, it tells us that it's perfectly fine to create the hash map from in memory and add properties to it, but as soon as we load it in the JSON, we deserialize it from the JSON and then quit. There's something weird going on now. So one thing that I'm thinking of is when you do JSON parse, there is a allocator that you get, which is used with this. Now it depends on if you're using, like, the allocator you get can either be an arena allocator or any other allocator that you would put in. It depends on the parse function that you call when trying to parse something. So when we do that, let's go to property, JSON parse, somewhere here. We do inner parse. Now, yeah, there's inner parse and inner parse from value. So yeah, and then we're using that, but we're using this allocator. So this is like a leaky sort of parsing. There's no like arena going on. Well, it depends on who called this function, JSON parse function. But let's just think about this. Here we're allocating a string. We're freeing it up here, We probably shouldn't free it up here, maybe then, because that's probably taken care of. Maybe. Where is that taken care of? Like, we're doing an alloc here, so it's probably our job to actually free it as well. I'm gonna look at here. We have like JSON array hash map. This is sort of the inspiration for this. Well, I basically copied over this code. So. Now this one actually doesn't allocate or remove k, but that is because we are putting it into the hash map here as well. So it should exist. It should be there. It shouldn't get deallocated, but we are deallocating it here because we are also duplicating it into this function, into this thing that we actually put in. So yeah, like I don't understand what the issue is. Is the final statement here, or not final, but we're freeing up the K. If we don't do that, then there's gonna be a memory leak, but I guess we'll try it. I mean, we are using an arena allocator that's gonna delete everything anyway, so we can actually get away with not freeing it up there. Expected what? 62. Oh, remove that thing there. And now we still get the crash. But it's when we're freeing up this buffer, so it's like we're freeing up this string Z. That's when it becomes an issue here. Is it because it can't? Is it because it's like it doesn't have a 0 or something? Anywhere? Like we are duplicating with Z here, so we should get that. That should get put there. Same thing down here. And that is not used to, yeah, like we're allocating the capacity. We're setting this here. This is the new, so we're looking for the sentinel or length as the maximum. Okay, so that's the length. And then we're just buffer printing that to our buffer. So and here's like when, oh yeah, we're parsing a string. Oh yeah, so we can actually parse it as we could parse it as a string Z as well, if, I guess, if we want. Maybe that's what's making things weird. Because the problem here is that we're dealing with like object keys, and they have to be handled like differently than values. I think you can't just parse like here we're looking for a token. You can't just like, oh yeah, I want to parse a string here. I don't think. You have to like do this weird thing. Like, why can't you just parse the next token as like a string? I'm not sure. Yeah, we're looking for object begin, and then we're looking for like the next token. I guess it's like it has to, I mean, it has to be either object end or a key in this. This can't be the solution because no. It is something to do with it not finding the thing here. Let's take these back and let's go over to the string, and we're going to allocator free here. So the buffer we're sending in is a zero terminated buffer. It has a length. This is just a type conversion. Like, well, you get a slice, so bytes length plus sentinel right. If you have a sentinel, then you put another length in there. So this is in bytes. Okay. Oh, it does a const cast. Oh, I guess I could have done a const cast. Okay, but anyway, memset. Here's the where it crashes. I believe. Yeah. So it's like a seg fault. Why do we do like a const cast? I mean, if it's read only, we should crash. Then okay. So I don't understand. Is it something else? No, it's when we deinitialize somewhere here, a string. No, string edge. Is when we deinitialize the key. Yes, that's where things go wrong. And the keys are generated here. So I don't understand why it is like it is. Is it because we're allocating the key? Oh, I see. I think I see what the issue is. I think it's because we're allocating the key here, but in the arena it's gonna get deallocated. Are we not properly cloning it? Is that the issue? We're not properly cloning this thing. Oh, I think that's the issue. I think we're not properly cloning this thing. We need to have a clone function here. I don't know. Let's see. Allocator. Right. So cloned map is equal to clone. So what does clone actually do? It creates a copy of the hash map, which can be modified separately. So I think it just copies the copy uses the same context as this instance, but is allocated with a provided allocator. What? Okay, maybe it's better just to create a new thing. What? Why do I get this weird autocomplete? It's like it's not really understanding what's happening. Can I specify like capacity? Promote. No. Re-init. De-init. No, I'm pretty sure you should be able to set the capacity. Where do you ensure capacity? Ensure total capacity. Yeah. So we make it empty first, and then we say ensure total capacity, which is gonna be the new capacity is self map capacity. Okay. Turns total number of elements may be present before it's no longer guaranteed no allocation. So that's the capacity. We ensure that. And we can then we put this thing here, assuming we have the capacity. The key is now k.clone, which we don't actually have on string Z. So let's add a clone function. Should be easy enough. return self, no, return init self. Does that work better? Okay. And the initial slice is self dot slice. All right, let's clone. And then we have value. So let's clone. We need allocator as well. Okay. And then the value is just v. Yeah, that's just v because we're gonna get like just the, well, we probably want to clone the value. Yes, we want to clone the value as well. So the value has to have clone functionality in order to be able to use this in that context. Yeah. So if you don't want to use clone, if you want to use clone, you have to implement clone on the values, on the value type. If you don't want to use clone, then I don't think you have to do that. So let's go back now to property. So, okay. If we just go back a little bit and explain the problem here, what I think is happening, and we'll have a hypothesis here. So we're crashing when trying to deallocate this, and specifically the keys in this hash map. And we have this custom JSON parse function, which deserializes the JSON into the correct format, where we're using the string zip keys, which we are initializing here. However, in our sort of generic document code, we're also like the general deserialization algorithm works by reading the JSON file, deserializing the JSON into whatever type you want to have, the document type. Then it does it by an arena allocator, which is part of the JSON sort of functionality. You can then deallocate using the arena, so you get rid of all the memory leaks that might happen in here in the JSON deserialization part. Then what we do is we clone. Well, we clone before we deinitialize, because otherwise it would crash. But we clone the entire thing to get a fresh sort of copy of the entire thing, so we don't have a bunch of weird allocations that might hang loose from the JSON deserialization. So we get a fully managed, memory managed like copy of the deserialized document content. But what I think was happening is, what that requires is everything needs to be cloned properly. And if it isn't, then when we try to deinitialize the document, it's going to try and free up stuff that has not been properly cloned. It's just been copied over, it's not been properly like duplicated. So I think that was happening. That's what happening with this thing here. We're producing a new string Z key in the arena allocator, but then that gets deallocated and then used in the application, and then by some miracle it doesn't like get reused for something else. So the data is still like there, I think, and it still works maybe. Well, we're not actually using the data, so I don't know about that. It might have actually started crashing before, like when actually trying to use the Z key, the string Z key. So yeah, so now when we implement this, we have clone here, and we're using yeah, we should actually do self fields.clone now. Okay, so that should actually clone everything, and then we don't need to do this either. Okay, fingers crossed. Actually, I'm just gonna check something here. Okay. Array hash map 47. Okay. Member function expecting one argument. Oh, right. So we need to put the allocator here as well. That's right. Okay. It loaded, and now we can quit without crashing. Okay, so that was the issue, I think. Also, I want to try this because, well, actually, I'm not gonna touch it right now. I was gonna try pointer casting from a slice directly into a zero terminated slice, but I'm not gonna do that. It would be interesting to know if it crashes or not. Actually, no. Let's not do that. Let's not do that. I don't want that knowledge in my head. Okay, so yeah. So now we're cloning it perfectly here. Okay, cool. So also another thing that I was thinking about is this property string. The value here should probably also be a string Z, because it's gonna be yeah, the value. So actually, okay, I also thought about this. This is kind of weird. This property object is supposed to be a description of the properties available. However, it also contains the values. But we actually have two different things we're talking about when talking about properties. We're talking about sort of the property schema, which defines what properties there are, and what their names are, and what their types are. But then we also have like the instances of these properties in each entity, or the component, or the, yeah, in each entity there's going to be like instances of the properties, and those properties are gonna be per instance, yeah, of per entity instance. But here we have like value, which is kind of, I guess it could be seen as sort of like a default value, and not like the instance value. It could be instance value as well. I mean, we could use the same property. We could use the same properties when, like the same property structs when implementing this in the entities instances. We'll see what happens here. But I think, yeah, we'll keep this string, but this is probably better off with like a string Z. And then we actually need to put a capacity. Maybe I'll remove the capacity thing, but because that's just a hassle to deal with. I just realized. Why did I add that from the start? I don't know. I don't know. But so this string is like, it's really unknown what the maximum value is. I'm just gonna say 256, because it's like, why would you have more than that for a string in the game? I don't know. It depends what it's supposed to be. Like if it's a book, you might want to have like a whole bunch of these. you want to set the thing to be a lot more, but I'm just gonna start there. Maybe we'll adjust string Z to actually not take capacity as a thing, you know, and it will be like dynamic. Maybe you have one that is like absolute maximum or something, I don't know. But yeah, anyway, so now we do have that. Let's see. Deinitialize. Yeah, so now we can say value deinitialize instead. And this one is instead is like initialize, it's like init. No, it's self value clone. So it's a bit easier, the interface there as well. Okay, probably want to have like an initialize as well, but let's start to draw this out now. I'm just gonna try this again here, see if we can add a bunch of more properties. We can do that. We will save, we exit, we have no issues here. Awesome. Let's open up this guy, and here you can see we have all these new properties here. So all we need to do now, well, all we need to do, but we have a lot of, this is a long road ahead of us to actually implement this fully with the component stuff, especially like not only on the editor side but also on the game engine side. But we're gonna keep trucking here because it's fun. I felt like when I was saying that, it was like I said it in almost like an angry manner. a little bit of irritation. It is fun. It's also frustrating sometimes. But okay, let's continue here. So it's gonna be awesome when we get this working, though. That's what I'm looking very much forward to that. So yes, let's go to layout, component, let's hide you. Alright, so we have new property. Now I want to have, like, before this, I want to have, or do we want it after? Let's put it after so that the plus is like always visible, basically. So now we're getting into this weird tree view thing. So we can actually start to create a tree view of the properties. Let's try and do that. Tree push, pointer ID, tree pop. Okay, you know what I'm gonna do? I'm gonna go to the Ingri manual site, and I'm going to look for, I think, tree nodes. Here we go. Basic trees, hierarchy lines. Not sure what that is. Draw lines, full. Oh, it's these ones. Okay, yeah. Sure, why not? Draw lines to nodes, full. I mean, why not? So let's look at this one. We have a bunch of checkbox. Here's the tree. So here's the root of the tree. I guess you do tree pop afterwards as well. Oh wait, here you also have a tree. Oh, that's the main one. I think this tree pop is for this one, which is like this outside here. But I'm interested in parent. So here we have parent, and there is tree pop, and then this is that, and this is that, this that. So yeah, and then you can put content also in there, which is really nice. Whoops. So I guess you start with tree node, and then you can put flags in there, and then yeah, that's it. It's just tree node and tree pop. Then you can put whatever you want in there. Okay. 3 node, 3 pop. So let's go back here. So we have 3 node. You could put flags in there as well. I'm not sure what flags we want to have. I guess the draw thing. Wait, what was it? Lines? Wait. Nav left jumps back here. No. Framed. Base flags. Where is this? Okay, so there is apparently, yeah, default open should be true. Allow overlap, I don't know. Bullet, frame padding, framed, sure. Get some styling in there. Leaf is false, I think. No auto open. Note tree push on open. Open on arrow, open on double click. Okay, open on arrow should be true, I think. And then span selected, no. Open on double click, no tree. So I'm not sure, I cannot find like the draw the stuff. But like draw the lines, but okay. This needs to be in an if, and then we do defer 3 pop. Okay. And the idea then in here is like we go through all of the properties. So I'm gonna create this function here. I'm just gonna assume that it exists now, so that we'll get out the property, and then we'll put in a tree node again, and the label is actually this is gonna be like probably want this to be like a KV thing. Do we want this to be an iterator then is the question? Yeah, because otherwise we have to allocate like an array here. So let's make an iterator. Property iterator. And we have to do while next, and we'll get the property out there, and we're gonna have a key, and then the flags. So the key is like a string v, so I'll just do slice, and then we have flags. Wait, I thought we didn't have flags on this one. Yeah. So then we have if pop. Why am I putting it there? Okay, and then each property is now going to have like a dynamic sort of property editor. So dynamic property editor for this property, and it's going to have to be mutable, I think, but let's start there, and I'll just define this for now. We're gonna need context, I think. Well, we'll see what we need. So this is property. I need to add this to lib. Return documents property. Okay. And here we do a switch on property, and if it's an object, we will do a object property editor. Else, I guess we'll do float as well because we need it. Float property editor. Else, we are going to do, I guess, a panic property type not supported in editor. And this is gonna be the tag name of that. 1 second here, just got a call. Oh yeah, I totally forgot I actually have an appointment soon here, so I have to go pretty much right now. But yeah, we are going to continue with this next time, so hopefully tomorrow. And yeah, that's it for today, so hope you have a nice time here, and have a nice day, and thank you for watching, and I'll see you later. Bye bye.